Okay, we are going to look at topic 3.3. We are on day 24 of our calculus journey here in AB Calculus. And our goal today is to learn the process, procedure, rules for finding the derivative of inverse functions. So our learning objective is to calculate derivatives of inverse and inverse trig functions. The inverse trig functions you will do in 3.4, and I have other videos for you to watch about that over for homework. Okay, so let's talk about inverse functions first. Let's remember some things about what it means for functions to be inverses of each other. Okay, and the reason we learn this now is because it has to do with chain rule and taking the derivative of composite functions. That's actually how we get to the formula for the derivative of inverse functions, is using what we know about chain rule. But first, let's talk about what we know about inverse functions. So a function, we're going to call it g, is the inverse of another function f if and only if these two things happen. If you do f of g of x, you end up back at x, right? For each x in the domain of g, which basically means if you do g of x and get all your answers, and then you run those answers back through f, and you end up where you started, the idea is that these two functions undo each other, and you're just left with x equals x, okay? So that's one way that it has to happen. It also has to work in the reverse order. If you do g of f of x, you should also end up back at x. And these two things are the equations that we use to prove that two functions are inverses of each other. Okay, so the way we denote inverse is with this f to the negative 1, right? So it's not, we got to be really careful here. This is not an exponent. So this notation, nobody really asked me about it if I thought it was okay or not. But that notation in this context, that is not an exponent. This is not where you take it and put it. It's not 1 over f to the first, or not even 1 over f prime. We got to be careful there. This is not 1 over f. When you have a function with the negative 1 as a superscript like that, that is always going to be called f inverse. And it just denotes, it's one of the ways we denote the inverse function of f. Okay? So properties of inverses. If g is the inverse of f, then f is the inverse of g. The domain of f inverse is equal to the range of f, and the range of f inverse is equal to the domain of f. That basically means x and y switch places. That's one of the ways we find inverses, is that we switch domain and range, which basically means we switch x and y. And then a third thing is that not every function has an inverse, but if a function does have an inverse, its inverse is unique. So let's look graphically at what happens here. So let's say that this is our original function, f of x. Okay, we're going to graph it like that. Okay, and it has the point, we'll call that point 2, 4. It's not drawn to scale, but we'll say that it has the ordered pair 2, 4 on that function. Graphically, the inverse of f is a reflection across this y equals x line. Okay, so graphically, they are reflections over y equals x. And if f of x has the point 2, 4, then f inverse of x must have the point 4, 2. It's required. So every xy becomes a yx over here. All right? That's kind of just the basics of the inverse. So knowing that and remembering that, we're going to work through this example. Normally, I would have you work through this just on your own, but we're just going to do it together. So the first thing is that we are told that f of x is equal to x cubed. And then it gives us an equation for f inverse of x, which is cube root of x. That should make sense, because if you cube something and then take the cube root of it, those two things undo each other, and you should just end up back where you started. So those are inverse functions of each other. So knowing that and knowing about function notation, let's evaluate all these things. We're going to do all these things with f first. Okay, so all of a, b, and c have to do with f of x. Okay, so we're going to do f of 2. So to find f of 2, we just plug 2 into our function. So it's going to be 2 to the third, which is 8. So we know that this function goes to the point 2, 8. All right, f prime of x. Well, if f of x equals x cubed, then f prime of x is 3x squared. And f prime of 2 would be 3 times 2 squared, which is 3 times 4, which is 12. Okay? All right. Now let's look at these inverse functions. Okay? F inverse of 8. If we do f inverse of 8, we are just going to plug that 8 into the f inverse function. So cube root of 8 is 2. So notice that the inverse function has the point 8, 2. This one had 2, 8. This one must have 8, 2. It's required. Okay, what is the derivative of f inverse of x? So I would want to rewrite this to find the derivative, x to the 1/3. Okay with that? So this is weird. It's hard to see the derivative, but if we're asking for the derivative of f inverse of x, we call it f inverse prime of x. So you gotta be really careful with your negatives and your ones and your primes that you can tell the difference between all of them. All right, so f inverse prime of x, we're gonna bring that 1/3 down in front. And then we're gonna subtract 1, so 1/3 minus 1 is negative 2/3, okay? That ends up being, when we rewrite it, that becomes 1/3 times x to the positive 2/3. And now f inverse of 8 is going to be 1/3 times 8 to the 2/3. The way we do 2/3 as a power is the bottom root is the cube root, or the root, the bottom number is the root. So we're going to take the cube root of 8, and then the top root is your power. So we're going to do cube root of 8, and then we're going to square it. Okay, so we do 1/3. Cube root of 8 is 2, and 2 squared is 4. So we get 1/12. So what I want you to notice here is that the derivative of f of 2 is the reciprocal of the derivative of f inverse of 8. So these are reciprocals of each other at each other's domain or range, right? So they are, what do you notice about your answers to C and D, or sorry, C and F? They are reciprocals of each other. Okay, but this one is with the original x plugged in, and this one is with the y for this one, which becomes the x for f inverse.